Well, hello, and welcome to our latest technical video here with Johnstone Supply Cafferty Group. Today we're going to be looking at some pressure switch diagnostics on this Goodman furnace here. So in order to get started, we're going to need a couple of instruments. We're going to need a basic electronic manometer, and you could use a MagnaHelic or anything that reads in a graduated capacity of inches water column. So you're going to need one of those. As well as a digital multimeter and probably a 6-in-1 screwdriver, maybe some nut drivers. All right, now that we've got our tools, let's go ahead and get started. And as you can see here, we have an error code of EE2. EE2 indicates that we have a low stage pressure switch that is stuck open or not closing. So as you can see here, we've identified that this is our low fire pressure switch here that taps into our draft inducer, which measures our vent and verifies that our venting is established at the proper draft. So we're going to make sure that we have power to this switch. We have our digital multimeter right here, and we have my other lead connected to the common side of our low voltage control transformer, and we're going to verify that we indeed have power to the switch, which we do. 27 volts to that switch. Let's check the outlet of the switch, and we see that we have 0. We have voltage going to the switch, but nothing coming out of it. So we know that that switch is in fact not closing. So this next step is very important because what we want to do is measure the actual draft that this switch is seeing. Now if we look on the rating of this switch, we see that it is rated for negative 0.72 inches water column. So we want to make sure that that switch is actually seeing the correct draft. Because if it's not seeing a negative 0.72, that means the switch is doing its job. It is not closing and not allowing the unit to operate. And we need to find out why we don't have the correct draft there. Perhaps we've got a plugged flue or a slow condensate drain or a draft inducer issue of some sort. So this is why we want to check this with a manometer or pressure gauge to verify that that switch is actually seeing the correct draft it should. Now most manufacturers will tell you they want to see at least a consistent 20% higher draft than what this switch is rated at. So if you have a 1-inch pressure switch, for example, you would want to see that draft reading at 1.2. So I have my digital manometer teed in here. Now the T is very important. Well, we want to use the T as opposed to connecting directly to the draft inducer. Reason for that being is a lot of these pressure switches have an internal bleed port, which means they will bleed a little bit of draft to the atmosphere to read accurately, and we want to make sure that we're seeing that value while we're making this test. The other thing too is if we're having an intermittent pressure switch issue, we want to see what that switch is seeing while the burners are running on the furnace. So I'm going to go ahead and make sure that my manometer is zeroed, and we'll go ahead and give this a call for heat, and we will see what we are reading for a draft on that switch. Let's angle in a bit here and see what our manometer says. We're right about 1.8 to 1.9, somewhere in that general range, which is certainly more than enough draft for that switch to close. So we've got the correct draft going to the switch. We just do not have a switch that is closing. So in this case, I would call that a defective switch. So now I've got my replacement switch selected for this unit, and as you can see on this particular unit, I have both the low fire pressure switch and the high fire switch come as one assembly. These come together. Now on some units you may be able to get these individual switches separately and just replace the one that has failed, but in this case the manufacturer provides this as a complete assembly. It's always important to note when you are selecting a replacement pressure switch that you get the correct rating for that switch, rated in inches water column here. Make sure that you stay within the parameters of what your manufacturer requires for that unit. Also make sure that you have the correct size electrical terminals and that you have the correct size and configuration of your pressure ports as well. Now, a popular truck stock item in the last few years has been the adjustable pressure switch. It's a switch like this that comes with a variety of different springs that you can change tension on and adjust the actual pressure rating of the switch. Those have become very popular and they work well, especially for after hours calls. But if you're going to use one of those, the Fieldpiece pressure switch tester is an excellent tool to set one of those up with. What you can do with this is establish a given draft with a little pump inside of here, and then there's an ohm meter that connects to it as well, and this allows you to dial that switch in at a specific inches of water column. Instead of just turning the screw and guessing, this gives you a much more precise way of setting up an adjustable pressure switch. Who knows, perhaps we'll do a video on that sometime. All right, so now that we've got our switch, let's go ahead and get this unit reassembled and get it back on the road again. Okay, so now that we have our replacement switch back installed in the unit, we have our wiring connected. We still have our manometer connected here with our T because we want to observe this while the new switch is running to make sure that it is operating correctly. So we will go ahead and give this unit a call for heat. We will allow that draft inducer to start, and then we will monitor the operation of this switch. And again, I'm going to check and make sure that we have incoming power to the switch, and we will also make sure that we have the correct power leaving that switch, indicating that the switch has closed. You can see I have a solid 27 volts coming out of that switch. And now we are already establishing the sequence of operation. You can see our hot surface igniter is glowing and the ignition sequence is proceeding. Now, you'll notice I still have the manometer connected here. And I have this connected for a reason. What I want to see is I want to watch the condition of that draft while that burner is running. Now if you'll notice, when we tested this at first, without a flame in place, we had like 1.8, 1.9. Notice that once the flames light, our draft begins to go down. It's because we have the flue product, we have the burner, all of that process going on in the heat exchanger, going to lose a little bit of that draft. So we want to make sure that we're able to maintain the required draft, that 0.72, while that burner is running and while the system is operating. Oftentimes with nuisance pressure switch lockouts, what you'll see is an issue with condensate, perhaps. Like we were building up condensate in this elbow, or if the unit was not level front to back and was starting to hold water in the heat exchanger, sometimes you would see this draft, you would see this start to drop, or you would see it spike down. You would see it go from like 1 inch down to 0.6 and then back up to 1 inch. And that's not what we want to see. We want to see a consistent number there. Of course, due to wind conditions and condensate and temperature, it's going to drift a little bit, but we want to see it fairly stable. This looks really good. I'm really pleased with that stable of a draft on this particular unit. Another reason that I mention this too is sometimes, especially on units that use full current through the pressure switch, you will sometimes see or hear the gas valve chatter. you'll see the chatter in the gas valve, you'll see the flames flickering sometimes, and if you have a manometer connected to that draft inducer, you will see that your draft is getting very close to the setting of that switch. And what can happen is that pressure switch can flutter fast enough that it will chatter the operation of the gas valve, and you'll lose flame and lock out on a flame blockout or loss of flame error before you will see an open pressure switch. So that can often be an issue. But again, all of that can be caught if you have a manometer teed into that, watching that draft the whole time. Like I say, this looks really good. I think we'll go ahead and pack up our instruments here and call this unit ready to go. Yeah, thank you for watching our video. We hope you found this helpful. Please check out the other videos on our YouTube channel. And as always, we thank you for your time and thank you for your business.